All right, everyone. Good morning, good afternoon, good evening, or good night. I am Floyd, Fearless Leader Holder, and I will be your guide through today's lecture material. Before we get started, though, one big consideration to make. I'm making this lecture video in August of 2022, and you might be seeing this a year or two from now. Just keep in mind as the semester goes on, I do add things, I do take things away that makes the actual in-class lectures the best they possibly can be. So you might see a few things differ. Primary thing you just want to go back and keep in mind, the core material will be the same. Just be on the lookout for those particular changes. Now, as we get started here, this is going to be the first of two lecture videos looking at, if I could find it, that'd be a big help. Taking a look here at the introduction to geography. Now, in going through and introducing ourselves to geography, today we are going to answer those fun, fantastic, critical thinking questions we all learned about way back in the day in our English classes. Question number one, therefore, is going to be who, as in, who are geographers? Now, geographers are scientists that spatially analyze the world. Of all the words you see up here on the screen, one word stands out as something you might not have heard about before. That one is spatially. A key term here is spatiality, or the perception of relationships in space between objects. As you go through and do different things, start thinking about how you might view something as really close by and others might view things as really far away. For example, I like going to see my two favorite high school football teams play in the fall, Highland and Ira. And as I try to go to some road games, they're typically, for at least for me, very far away. But to a football mom, it's probably just like driving down the street. I'm gonna go see my little boy play. Oh, kind of a thing. Now, in another sense, geographers are like this guy on the screen. Here he is in his lab with his lab coat and his Bunsen burners and his beakers. And if you're an actual chemist, you know what these things are. Please don't blow anything up unless that's what you're trying to go back and do. But that's just me. Officially, though, this guy is like a chemist. And chemists work with chemicals, hence the name. My mom's father worked on some of the hydrogen bombs over in the Bikini Atoll. And one of the things that he used to have before he died, and we returned it to the university, was a vial of uh, mercury. Really small bottle, but it weighed a ton, which was really cool. Now, you mix chemicals together and you get some pretty cool, fun stuff happening. This guy put some stuff in a beaker, lit it on fire, poured it on the floor, and this place became lit. That's just me, though. If I could be in this class, I would totally love to be there. That's just me, though. Now, you mix chemicals in certain locations together, hence geography, you get some more pretty cool, fun stuff. What you're looking at here is located in the outskirts, in the probably not the outskirts, but the rural areas of Turkmenistan. Uh, the giant gaping hole that you see here on the ground that's glowing is known as the gateway to hell. About 60 years ago, some scientists, some soldiers, Ma and Pa were out there and they were like, oh man, Muriel, what's that smell? It's a little hard to breathe over here. Oh, that gaping hole in the ground is emitting natural gas. We should light it on fire and put it out to make sure that we nobody else gets hurt. It's still burning 60 years later. They were trying to go through and let it burn it out, but it's burning to this day. What you're looking at here on the right is what it looks like at night in a more video format. It literally looks like the gateway to really amazing thing. Now, beyond that, you have some bioluminescence coming ashore here on night over on some lush tropical island. Beyond that, there are rocks that move on their own in the desert, actually moving so fast to the point that they actually leave tread marks in the ground, which is utterly fascinating. Beyond that, you have some poisonous gas trapped in the ice. When things begin to melt, you might not want to be there. And my personal favorite, volcanic lightning. Whoa, that's just me. Now, looking at geography and chemicals, there's three basic things we go back and use to do the practice here today. What you're looking at here on the right is Eastern Africa, showing where the Nubian plate, the Ethiopian, the Somalian plate, and the Arabian plate basically go back and interact with one another. These are all examples of physical features of the Earth. If you've taken this class for physical geography, we're going to go through and discuss this area more in depth and discuss the impact of changes that you see there. Now, geography chemical number two is those funky, fresh things that you and I go back and do. The next time you find yourself at the pyramids, if you don't go through and make yourself into a human pyramid, I don't know why you even went. Next time you go to a festival, hop in the mud pit. If you go to Southeast Asia, these women have long necks. This families here at home has lots of guns. Japan is Japan. And who's to say women should be covered up or not covered up? What's the difference there? These are the human things that you and I go back and do. We're all human. We all look a little bit differently, and we all interact and do things in the world that much more differently. And last but not least, kind of bringing the interaction of the prior two together is something known as technology. We use a program called ArcGIS to make our maps that allows us to build up different layers and create really cool images that we can use to explain what's going on in the world. Now, speaking of what, that takes us to question number two. As in, what is geography? What are geographers doing? And so much more. Now, the simple definition of geography is the study of where things are. Take a look around your house and look at the carpet on the floor. If you see a particularly worn spot, that's just indicating where it is. Over there by the door, it is a worn spot on the carpet. The official definition of geography kicks it up a notch. Geography is truly the study of how observable spatial patterns emerged. If you go over and look by the door and you see that the carpet is beginning to get worn down a lot in that one particular spot, that's known as a high traffic spot. You have lots of people walking back and forth doing different things, and accordingly, over time, versus over in the corner where not a lot of people stand, the carpet's going to get worn down a lot more over there versus somewhere else. Accordingly, we have a key saying. It's about breadth, not depth. Therefore, geographers study the surface of the earth. Yes, we're caring about what's going on at the core of the earth. Yes, we're concerned about what's going on in the atmosphere and outer space, but we're primarily concerned with how those two areas go back and interact to create the surface where you and I go back and interact. Why do we have mountains here and valleys over here? And how do those mountains and valleys go back and indicate where you can and cannot go? Now, looking at what we can go back and study in geography, there is two primary subdisciplines. Here, first and foremost, on the left is physical geography. That's what 1301 is about, hence the name physical geography. You're primarily going to be concerned with what's going on over here in the physical world and kind of this teal, turquoise, light blue, whatever color this is supposed to be over here. If you're taking 1302 human geography, you're primarily concerned with what's going on here on the right side of the screen and towards the bottom. But I think my favorite, though, might be 1303, which looks at the totality of these different factors. Why is India India? Why is Southeast Asia Southeast Asia? Why is the Middle East the Middle East? Why is Northern Africa very different than Southern Africa? How do all these different things interact with one another? That's 1303. Now, when out in the field, geographers like to ask questions. Here I am taking the overnight sleeper express from Cairo in the north of Egypt to the south of Egypt and the city of Aswan. And I'm so excited at midnight, I ask myself, where am I? That's actually a very good question at that particular point because if you look at the window behind me, it's dark, it's black, and you're in the middle of the desert. So just kind of keep that in mind. Now, you might also ask, why do people in Asia use mass transit so much? They have different urban design, different urban form. Where we're using mass transit is much more emphasized and is much more cost effective. Versus here in the U.S., where in a lot of places parking lots have been put in, as opposed to bus stops and mass transit rail lines, amongst other things. And my personal favorite, here I am outside the Trojan horse in Troy. Why are the horses here and not there? Why do animals exist here but not over there? And why do we have these animals over here but not over there? Take a look at animals in the desert, they don't typically have a lot of hair. But if you take a look at animals way up in the Antarctic and in the Arctic, they typically tend to have a lot more fur and a lot more blubber because they need it to keep warm. Now, here at the halfway point, we've reached question number 3. Where? Where are we? Where are the things we're trying to study as geographers? To do that, we do something called create geocodes. Geocodes are a set of geographical coordinates corresponding to a location. Now, geocodes are things that you and I have gone back and used for years, but you might not really think about what they are in the grand scheme of things. Here on the screen in the middle, we have your lines of latitude that go east and west, left and right. Whereas over here on the right, you have your lines of longitude that go north and south from the top of the earth down to the bottom. These are known as lines of latitude. These are known as lines of longitude. In a more casual sense, these are meridians. These over here are parallels. These meet at this top. These never meet one another. Now, if you take a little bit closer to home, particularly way out here in West Texas, if you're flying into Lubbock, Midland, Odessa, or Abilene, you might notice that there's a lot of squares on the ground. That's because of the way the land was initially subdivided, using something known as the township and range system. Basically, you kind of use an XY coordinate plane to go through and develop some squares called sections, and then we have subdivisions of the sections, and then we can have a subdivision of the section. For example, you might own the northeast quarter of the northwest quarter of the 24th section of Township 3 North, Range 4 East. It's a bit long winded, but if you actually go look up property records and descriptions in many cases, particularly farms and ranch, that is the actual description that they go back and use. Now, getting a bit close to home, we also can use your home address. 123 Main Street, Dunedin, Florida. Type the address into Waze or uh, Google, and it will actually take you to where your home location physically is. Now, if you get out on the road, or if you're out on the road in a hotel, Or if you live in a big apartment complex, the street address is one thing, but you also have to go back and consider your room or unit number. Over here, they used a fancy way of using a light to create and draw the room number over here on the wall just outside the door. The next time you're at the grocery store and you look at the aisle marker, that counts. That's a way of indicating where in the store cat food, cat toys, wine, and meals for one are conveniently located near one another. Now, for those of you who love math, remember the XY Cartesian coordinate system that you used in class. Coordinates are 2, 3. You go 2, you up 3, and you get your particular point there on the graph. Here on the left is kind of the same thing that adds a bit of a third dimension because they also have the z or zeta axis, adding a bit more intrigue to the matter. Now, looking at a good general geocode example, this is a map using general point markers to indicate where things are. The different point markers are different colors, and they also have a little symbol on there indicating what's located at that specific point. We have a point indicating something's there, and then we have a sub symbol on the main symbol indicating what specifically goes on there. Now, up next, question number 4 is when. When did geographers do this? When did geographers do that? And how does it really go back and compare to different things in the grand scheme of things? Accordingly, guys, it's time for a history of geography. Now, prior to the 1900s, geographers were concerned with what this guy's wanting to do here. We need to make this fit onto this using only this. What the guy's holding in his right arm is the Earth. Many of you might think of it as a sphere, but officially it's an oblate spheroid, which is a sphere with a top and bottom that are slightly condensed and flattened due to the rotation of the Earth, making it a little bit wider than it is tall. But because it's a sphere and you go back and crush it, it creates some issues. Putting it down onto paper might not work out all that well if you just do it really, really fast taste or post haste, I guess is the thing I should go back and say. So, how do we map the surface of the Earth onto a flat sheet of paper? Things that are round don't always go all that well onto a flat bottom. Now, one of the best early examples is seen here. This is called Ptolemy's Geographia, which is one of the first true world maps that was ever tried to be made by someone. The main thing you want to take a look at it is the lines going north and south, meridians, lines going east and west, left to right, parallels. That basically gave way to today's modern latitude and longitudinal coordinate system, which is seen over here on the right on a Mercator projection map. When we get to techniques of geographic analysis, we'll look at this map a little bit more in depth and why it's so cool. Now, also prior to the 1900s, not only were we concerned about how to map a round object onto a flat sheet of paper, we were also really wondering, where are things? How do things relate to one another? What's the spatial relationship to different things? So number 2 is, where are things? One of the earliest, greatest attempts you could go back and look at is seen here, called the Candido map of Korea. It's considered to be a very accurate map of Korea, but the further away you go into China and over here to Japan, it doesn't quite have the same impact as what it might be in other particular places, but it's a real great early attempt. Probably the granddaddy of them all is seen here on the right, known as the Cassini map of France. They basically got 20 to 25-foot long chain links and walked around the country for 14 years, mapping out where things are. and how they go back and relate to one another using roads and things of that general nature. And they actually created a very large, very accurate map of France. From top to bottom, the map is like 30 feet tall, another 30 feet wide. It's a really, really huge thing to go back and consider. The French at the time were actually so concerned about this mapping process going through that because they were afraid for their taxes to go up. And in the 14 years where this was going on, you actually had the French Revolution, and their taxes went way up because they were more able to accurately map and deduce the size of said property. What this is all basically turned into today, though, is programs like Google Earth that you see up here on the top right of the screen. This is a more simplified version of something called ArcGIS, which allows you to have a sub base layer that allows you to go back and put additional layers on top to create some very personal, intriguing maps of the Earth we all know and love today. Now, this first era is concerned with matters of form, which is the external appearance of a clearly defined area, its configuration. We're just trying to develop basic mapping skills. We don't have some ulterior motive, ulterior purpose. We're just trying to make things the best that they can go back and be. Now, for the second era in the early 1900s, we got to bring in Will Ferrell. He wants more cowbell. Yeah, that's a good map, but what can we add to it? What can we do to it? How can we make it cool? As the cool kids say. This is something known as thematic mapping. The map you're looking at here is called Mackinder's geographical pivot. Basically, he argued that if you own this particular area of the world, Eastern Asia, Western Europe, that if you controlled it, you could basically go back and dominate the world. These insular crescents, the inner and outer, are places that you could go back and control. That's great, but as long as you control this area, you could basically do whatever you want, wherever it is you want. You have the resources, you have the control, you have the areas in your best interest. Now, in the late 1900s, geography has not been immune to what's going on out there on the world. Late today, number one is something known as emphasizing social justice. The primary thing to be considered of here with emphasizing social justice is that we get a lot of very interesting alternate visuals. The map that you're seeing over here on the right is how the world map looks upside down. Who says North should always be up on the map? Should Russia really be on top? No. Send them down, down to the ground. Same with you, Canada. Looking at you, US. It's time for South America, South Africa, Australia to finally be on top. Kind of a thing. Or more importantly, the top map, the top right map, and the map on the bottom left that is an outline of the continents. Those maps are both Mercator projections. These are really great maps to use for navigation, but if you're really trying to show who has the power, who has the influence in the world, look at what you do with the map on the bottom or behind the black outline map, I guess I should say. If you control for area, Canada, uh, Russia, Alaska really aren't that big. If you go out and take a look at Africa, Africa is actually heavily undersized when you use the Mercator projection. Africa is actually a very, very large continent and place to be. When I flew to South Africa, I flew through Qatar, and flying from Texas to Qatar was a 15-hour flight. But flying here from Qatar to South Africa was actually an additional 10-hour flight. It's a huge, huge place. You know, let's make sure we show the proper size of landmass equality, as the cool kids say. And late 1900s to today, number two, I sort of already touched on it, but I got to really emphasize it here again. Start thinking about technology. Start thinking about how almost everything you do today can be done with an app. Pay for stuff, buy stuff, sell stuff, get paid for stuff, book appointments, schedule your calendar. It can all be done on your phone. Technology has made the calendar incredibly obsolete. It's just one of those things. One thing to keep in mind, only about 60 years ago, when working on different plans and structural things, these 100 guys that you see over here are all working using dividers and pens and whatnot to properly go back and develop building plans or whatever it is they're really trying to go back and take a look at and construct later on. Now, these maps and this final two eras are concerned with matters of process or a series of changes taking place in a definite manner to reach a current form. Primary thing you want to go back and consider here, yes, we know how to map, but how can we map better? Yes, I know how to clean my room, but how can I clean better? How can which chemicals can I use to not harm the environment? How can I properly do things? Big thing to consider, start at the top and then work your way down. It works a lot better, it works a lot more quickly if you go that direction. Now, one other thing to kind of go back and consider is also looking at geography as compared to history. We took a look at geography compared to chemists. They were both working with chemicals, but geography adds a location. Historians look at change over time. They're concerned with one physical point and they're concerned with how things changed over time. How did things grow there? How did things collapse? Who ruled? Who didn't? Things of that general nature. If you've ever been to Six Flags Over Texas, that name actually stands for something. It's literally taking a look at the six different flags that have officially flown over the great state of Texas. The French, the Spanish, the American, the Texan, the Confederate, uh, Union, Texas, the Confederacy, the Spanish, the French, and Mexico. Geographers look at change over area. In this particular case, we're no longer concerned with how things were at one time. We're looking at how they expanded over an area. Yes, today our land was small, but today it's grown out to this. What was the extent? What regions collapsed? What regions grew? So on and so forth. Historians look at change over time. Geographers look at change over area. Now, last but certainly not least for today, we got question number 5. Why? Specifically, why should you go back and study geography? Now, let's go to a cotillion, a quinceañera, if you're a part of a more Latin flair. Look at this lovely young lady who come down the stairs, and all of those suitors are out there just trying to sponsor her video. This belle of the ball truly is a desirable thing. Thing about geography, like this woman here, is a very broad field. It can be used all over, like accounting. History books have maps in them. This has maps in them. That has maps in them. Everybody uses geography. It goes through and helps them explain what's happening here and not happening there. Now, flashing back to the Obama presidency, the president was indicating that the biggest problem in the region is Jewish settlements. That's great if you're only looking at Israel, but if you scan out a little bit and take a look at what's going on out here in the area, there's a lot more other bigger things might be considered of. nuclear hazard in Iran, a civil war in Iraq, 100,000 dead in Syria, terrorists based in the West Bank, the Golan Heights, and the Gaza Strip. Looks like Egypt's on fire, I guess. You know? Geography enables the grasping of broad concerns, important to understanding national and international problems. If you're ever really wondering why the Middle East has all the problems it does today, it's basically after World War I when they subdivided the collapsed Ottoman Empire. They did a really, really bad job of controlling for the different ethnic groups and people that lived there. Realistically, here in northern Iraq, western Iran, eastern Syria, and southern Turkey, there should be another state known as Kurdistan, where the Kurdish people would go back and live. But more on that if you take my class and look at political geography in federal government and human geography. Uh, it's a fun thing to consider. And last but not least, here we have a map of the San Francisco Bay Area, if I'm not mistaken, that also goes back and takes a look at not just residents per square mile, but feet above sea level. Main thing you want to see is a lot of the population wants to be a lot closer here to the water, whereas people don't want to be so far away from the water. The big thing to remember here is that this is the only discipline concerned with understanding why and how both physical and cultural phenomena differ from place to place. Typically, in most places, poor people end up on the hill. Pardon me, rich people end up on the hill, but poor people want to be end up being closer to the water. If we go to places like Brazil and their love of the beach, poor people tend to live up on the hill versus rich people tend to live closer towards the water so they can more easily go swim. Now, one thing you're going to go back and see in a lot of these lecture videos is a two-sided exercise. The text here at the top of the screen is a statement indicating that era number 2 of geography is the best era of geography to kind of go back and consider. In class, if you agree with the statement, you would go to the left. On the right, if you go to the right if you were to disagree, and you could kind of stand in the middle of the room if you wanted to be a monkey in the middle. For me, at least, I really want to say era number 2 of geography is the best because I like a good theme. I like to sort of go through and do stuff. But I can't say I really like the stuff that's going on today, nor do I want to be the guy going out there with the chains, physically learning how to map the Earth. So I would agree with this one. Thanks for being here, guys. I hope you enjoy the video, and I look forward to seeing you guys in the next one. Bye, y'all.